Hello everyone. Today we will begin our discussion of data collection with an overview of enumeration. Now, enumeration is basically just any time we are trying to answer a question of how many blank are there. So, when we are dealing with enumeration problems, one issue that comes up is the population. Now, the population is basically just all of the individuals or items that we are trying to get a count of in our enumeration process. So these could actually be people, these could be other things besides people, so they could be objects, they could be animals, they could be all kinds of things. And we use the capital letter N to indicate the size of our population. So if our total population has 1,000 individuals in it, we would say that we would say we have n equals 1,000, or we have an n value of 1,000. When we're dealing with enumeration questions, there's a couple of different techniques that we can use to sort of help figure these things out. And those are censuses and surveys. A census is where we are doing a complete head count of our entire population. Examples of this would be something like the United States Census, which happens every 10 years. In this case, we are collecting data from the entire population of the US. Sometimes censuses can also be used for other applications, something like determining how many of some endangered species there are in the wild. This might be another example of when we might see a census. A survey is different from a census in the sense that we are using data from a portion of the population to draw conclusions about the entire population. So rather than doing a full head count of our entire population, we are just looking at a part of our population. And as we'll see in a minute here, we can use surveys where we're just collecting data on a sample of the population to estimate the size of our total population that we're trying to enumerate. Kind of going along with this, we have samples and sampling. A sample is basically just whatever portion of our population we are using for data collection. Sampling is our process of selecting the sample. And finally, we have these other two terms, statistic and parameter. The difference between a statistic and a parameter essentially lies in the difference between a true versus estimated value of something. So let's say that we have a population and we are trying to determine the average age of individuals within a population of humans. So the statistic, say we're using a sample to estimate the average age, the statistic would be whatever average we get from that sample. The parameter is the true average age of everyone in that population. So you can kind of view it as a statistic is an estimate of the parameter. The parameter is our true value for whatever piece of data it is or information that we're looking for. The statistic is the estimate that we get from our sampling process. Now, when we are trying to estimate the n value of a population, there's a couple different techniques that we can use. So one of these is what we call one sample estimation. This is basically just where we take a sample of our population, of a larger population, I should say, and we figure out how many individuals within this sample meet X criterion, and we use that to figure out how many individuals meet that criterion within the larger population. So what does that really look like? Well, sort of a classic example of this is figuring out the number of defective light bulbs in a large batch. So say we have a batch of 250,000 light bulbs. Well, it's probably not the most practical thing in the world to test every single one of those 250,000 light bulbs in that batch to see which ones are defective. So we can take a sample of, say, 100 light bulbs, and let's say out of that 100 light bulbs, 4 of them are defective. And we want to figure out how many defective bulbs there are in the total batch of 250,000. So the formula that we'll use to determine that looks like this. So we have K over N, lowercase n equals capital N over capital P. So in this case, this first part right here, K over N, is the number of defective light bulbs in our sample. So we would say K is the number of defective bulbs that we sampled. N is the size of our sample. And then N over P represents the full batch. So this capital N is the number of defective bulbs in the whole batch. Capital P is the total batch size. So in this case, we're trying to figure out the defective bulbs in the total batch, so it's this capital N that we are interested in. So what we would do in this case is multiply both sides by P. That's going to give us PK over lowercase n equals capital N. So in this case, capital P, that's 250,000. K is 4. That's our defective bulbs in the sample. And then this lowercase n, that's our sample size, so that would be 100. And what we find is that this works out to 10,000. So we are basically saying that based on the 4 out of 100 defective light bulbs in this sample, we are estimating that out of our full batch of 250,000, we have 10,000 defective bulbs. The second method that we can use for estimating N values is what we call two-sample estimation, also known as the capture-recapture method. So one sample estimation works really well when we know the size of our larger population and we're trying to estimate the size of a subpopulation. But if we don't know that, then we can't really use one sample estimation. This is where two-sample estimation comes in. So when we are doing two-sample estimation, we basically have really two main steps in the process, a capture and a recapture. So let's look at an example where we are trying to estimate the total size of a fish population in a lake. So the capture step, we are going to collect 200 fish from that lake, and what we're going to do is we're going to tag all of those 200 and then let them release them again, let them redisperse. And then we have the recapture step where we take another sample, let's say 100 fish, and we're going to count how many of those have tags from when we did the first step. So in this case, we're saying that 7 out of the 100 fish that we recaptured have tags, and we're going to now estimate the total fish population. So this right here is the formula that we use, K over N2 equals N1 over N. N1 and N2 are our sample sizes from the capture and the recapture step. Capital N is our total population size, and then K is how many of the recaptured individuals had tags. So in this case, it's the capital N that we're really interested in. That's the size of our total population. So what we can do is take this formula, multiply both sides by N, or capital N I should say, and we get Nk over N2 equals N1. And then if we want to solve this for capital N, we'll multiply by both sides by N2 over K. So what we get from this is that N equals N1 N2 over K. So if we plug in all of our plug in everything for this, basically, we have N equals N1, this is the size of our first sample, so that would be 200, times our second sample size, that would be 100. And then over K, that's how many of the recaptured individuals had tags, so that would be 7 in this case. So, if we put all of this into our calculator, then what we end up with is 2857 as our estimate for the population. This is how we can use one sample and two sample estimation to estimate the total size of a population. Thank you for watching as always, and I'm of course happy to help with any questions you have.